Hey guys, so today we are going to take a fascinating journey through the evolution of generative AI, revolution that's changing how we interact with technology. So we'll start from its humble beginnings with neural networks and trace its path to today's sophisticated AI agents. So let's get started. So it all began with the neural networks inspired by human brain structure. The key developments at that time were the perceptrons, the first artificial neurons, and then the backpropagation, the algorithm that made deep learning possible, and then the actual deep learning concepts came into existence, like the multiple layers enabling complex pattern recognition and prediction. So think of neural networks as the foundation of modern AI, just like how a child first learns to recognize the patterns, right? And then after neural networks, we saw CNNs and RNNs around 2012. The next breakthrough that happened with specialized neural networks. The CNNs are nothing but the convolutional neural networks. Basically, they revolutionized the computer vision and enabled image recognition and processing. And then the RNNs, recurrent neural networks, is what we call, handled sequential data like text and time series, right? And then they basically laid the groundwork for language processing. So these specialized networks were like giving AI specialized senses, that is vision and memory. That's what CNNs and RNNs made possible. And after CNNs and RNNs, we saw a big breakthrough, right? The transformer architecture around 2017. 2017 basically marked a revolutionary movement with the transformer architecture, because all the models before that came before transformer architecture did not have this self-attention mechanism. So the folks from Google, the researchers from Google, basically published a um, research paper where they proposed a new architecture, that is transformer architecture, that had the key innovations like self-attention mechanism, that is understanding the context, and then parallel processing, that is for faster and more efficient processing, right? The transformer architecture was like teaching AI to understand context and relationships, similar to how humans basically understand language. So that was the big breakthrough in 2017. And then came the BERT and the GPT models, right? The transformer architecture basically led to these two groundbreaking models, right? The BERT is nothing but the bidirectional encoding, understanding context from both directions, and then mastering language comprehension. That's what happened with BERT. And then the GPT, generative pre-training, is like introduced basically to generate human-like text. And each version of GPT was more capable than the last, right? So again, this was when AI started to truly understand and generate human language, basically. And then what we see today is like about the introduction of large language models basically happened. The key characters included like massive training data, billions of parameters, and a lot of emerging capabilities, abilities that these LLMs started having. And then it's like how a child suddenly starts forming complete sentences, right? LLMs showed unexpected capabilities at scale, and all this was made possible with the companies like Google, Microsoft, OpenAI, and all these folks, Anthropic, and all that. So, and then the foundation models, what we call, came into existence, and then these became the building blocks of what we call the modern AI applications. So the features included pre-trained on vast data sets, adaptable to multiple tasks. Companies started using these foundation models for different tasks, Okay, and then the transfer learning capabilities were also included in the foundation models. So think of foundation models as versatile AI brains that can be specialized for different tasks, right? And then we saw a very amazing, or what we can say, the novel approach known as the retrieval augmented generation, along with the other two prominent approaches like fine tuning and prompt engineering. So I'm going to take the side of retrieval augmented generation in this in this journey, because what happened was these large language models that trained on massive amount of data, they started hallucinating basically, right? So this hallucinating behavior was like these LLMs started basically responding with inaccurate data, sometimes made up responses, and very biased answers sometimes. So this behavior of large language models is known as hallucination. And then to basically mitigate this hallucinating behavior, uh, we saw three approaches, like I said: fine tuning, prompt engineering, and retrieval augmented generation. But in all these three, RAG started getting more prominent, um, because of all the good reasons. So RAG basically marked the integration of external knowledge. So that's how it basically mitigated the hallucinating behavior of large language models. The components included like vector databases for efficient storage, real-time information retrieval, fact-grounded responses. So RAG basically made this possible. This was like giving AI access to vast library it could reference while talking, right? So, so that's about the RAG approach. And then came the multimodal models, right? So what happened before? The LLMs used to take only unimodal approach, like text as input and text as output. But now you can ask LLM model, hey, generate an image for me, image of a horse eating grass. So now with text as input, you can get multiple type of outputs, right? So that's what the capability of multimodal models were. So AI evolved to understand multiple types of input, basically. So the capabilities were like process text, not just text, image, audio, video, cross model understanding, generate multiple types of content, basically. So multimodal models are like humans using all their senses together. So, and then after multimodal models, we saw AI agents, which every company now wants to build their own autonomous AI agents because of all their good capabilities, good reasons. Um, um, right. So, because of the features like goal-oriented behavior, decision-making capabilities, tool calling capabilities, even they have memory, right? So that's how special the AI agents are. And then, so think of AI agents as assistants who can understand tasks and take action to complete them, basically. And then after AI agents, we saw companies using multi-AI agent systems. So this is the latest frontier in the AI systems. That AI agents working together to complete a complex task. Basically, what happens, these multiple AI agents come together, break the complex what do you call input into subtasks, and each agent takes the subtasks one by one to complete it. So the characteristics include collaboration between specialized agents, complex task handling, emergent behaviors, and much more. So so these multi-agents basically like a team of experts working together, each bringing their specialized skills. Okay, so this is how um, the evolution of generative AI happened, and it is still growing. I believe companies like Google, OpenAI, Anthropic, Microsoft are all working very hard to basically make Gen AI a very good space for all the folks to build the next big innovative products and services. And I hope you enjoyed this whole video. And thank you.